NCBM 0324, Section 1.2, Solving Linear Equations in One Variable, Part 4. Let's look at some more fraction examples and other things that may occur. Still in example 3, let's look at Part D. We're looking to solve. Part D, we have 3 parentheses y plus 3 close parentheses, all divided by 5 is equal to 2y plus 6. So I do have a fraction. I'm going to look at my LCD. The values on the right-hand side, the 2y and the 6, think of it as over 1. So my LCD is going to be 5. And that won't always be the case, by the way. It just so happened that our 2 examples we've seen so far, the LCD is 5. But, these numbers can be anything really, depending on, the equation values in there. But it just so happens that this one's also 5. But we are going to do the same thing that we did previously. I'm going to multiply the left side by 5, and I'll make that 5 over 1 since the fraction is on this side. There we go. And then I'm going to multiply the right-hand side also by 5. Now something a little bit different than our last example. Notice that 3 parentheses y plus 3, all of that is being divided by 5. So it's almost like this whole piece is one term in a way, and it's being multiplied by that 5. Well, 5 divided by 5 is simply 1. And I'm getting rid of that 5 here. There's no need to multiply it through because it's already been divided away. And that's going to leave behind the 3 parentheses y plus 3, which is really nice, right? It got rid of that fraction for us. Now on the right-hand side, remember we want to keep that equation balanced. So what I do to one side, I have to do to the other. So when I say multiply the right side by 5, that means multiply every part of that right-hand side by 5. Now this is different from what we did on this left-hand side because we're not dividing both 2y and 6 by the same 5 value, right, that we could divide away. So it's a little bit different on the left side, but I still need to multiply by that 5. So 2y then times 5 gives me a 10y. And 5 times the 6 gives me a 30. It's nice and cleared away of fractions. We can continue on with our process. So parentheses, let's get rid of the parentheses on the left side. Distribute that 3 all the way through. It's being multiplied through. So I'm going to have 3y plus 9 is equal to that 10y plus 30. Then we'll start combining our terms on the same side. In this case, I'm going to put my variables on the right-hand side just to kind of mix it up a little bit. So I'm going to subtract 3y from both sides. That cancels the y value on the left, leaving behind a 9. Let's see, we have 10y minus 3y, so that leaves 7y plus the 30, and then let's subtract the 30. Of course, once you get the hang of this, you can maybe skip a few of these steps or combine some of these steps into one, which is perfectly fine. 9 minus 30 gives me a negative 21 is equal to 7y. That's 7 times y. So again, the multiplication property of equality, let's divide by the 7. That reduces away the coefficient on the y, leaving just the y term. Negative 21 divided by 7 is negative 3. Now we have negative 3 is equal to y, but the nice thing about that equal symbol is that we can flip around the order. So this is the same thing as saying y is equal to negative 3. And again, if we check our answer, taking that negative 3, plugging it into our original equation, we're going to come out to say that 0 does equal 0. Just so happens that both left and right hand side equals to 0, which is good because that means we have the solution. Okay. And that check, you may want to go through it on your own because there were two places that I needed to plug in my answer. It had a y value on the left side and a y value on the right side. So now what if we have multiple fractions? Let's look at part E. In part E, we have 5 halves x minus 1 is equal to x plus 1/4. Okay, so I have two fractions, and in this case, my two fractions have different denominators. Right, that minus 1, well, it's like over 1. The x is over 1 there. So my denominators are 2, 1, and 4. And between those numbers, my least common denominator is going to be 4. I can get all of these denominators to be a 4. So that 4 is what we need to multiply the left side and the right-hand side. So in this case, everything on the left gets multiplied by the 4. Everything on the right gets multiplied by 4. So I'm going to have, let's do the fraction part first over here on the left. 4 times 5, well, that's 20. 1 times 2 is 2. And if you feel ready, 20 divided by 2, I know is going to give me 10. Right? We can see that happening. That's still being multiplied by the x. Right? That multiplication of x travels along with it. Then I go to my second value on the left side. 4 times negative 1 is a minus 4. There's our equal sign. And we'll do the same thing on the right. 4 times x is a 4x. And then the 4 times the 1/4. We're going to multiply straight across. 1 times 4 is 4. And then 4 times 1 is also 4. But 4 divided by 4 is simply 1. So simplifying those fractions with that LCD built in takes away the fraction part, right? It reduces it down. Then we go with the same game. Subtract 4x to get the x values on the left side. And in the same step, I'm going to kind of jump a little bit here. I'm going to add 4 to both sides. So I get my numbers, my constants on the right-hand side. 10x minus 4x is a 6x. 1 plus 4 is a 5. And then we undo that multiplication, which, by the way, won't always be a multiplication here. Sometimes if you have a fraction, you may want to multiply to get rid of the fraction. It just so happens that our examples have been in that way, but it won't always be that way. So it looks to be like my answer is 5/6. Let me check it. So a little bit more work because of those fractions, but in the check, when we plug in that 5/6 into both spots of our x on the left side and the right side of the original equation, here and here, we're going to get 25/12. I'm going to have to get a common denominator, which I found to be 12. It just so happens that the left and right side are all 12. So I end up with 25/12 minus 12/12. And the denominators are the same, so I can subtract the numerator. 25 minus 12 is 13. On the right side, I have 12s again. 10 plus 3 gives me 13. So the equation matches up, right? Our solution checks out. That means our answer is in fact that 5/6.